to this tutorial where by the grace of our Lord Jesus Christ, we'll be able to solve paper 1 type of questions that have come on the topic of wave motion for pure physics. Without further ado, let us start with the video. The first question says, the following diagram shows one of the properties of waves being demonstrated using water waves. Which property of waves is being demonstrated above? Let us use this question to get to understand the properties that waves have. So, for pure physics 5054, which is our syllabus code, they are about 4 properties that waves have. Number 1, waves undergo diffraction. Secondly, waves undergo interference. And thirdly, waves undergo reflection. And lastly, waves undergo refraction. Okay. Wave diffraction is defined as the bending of a wave when it passes through a narrow gap or when it goes around an obstacle. Okay, so what I'm basically saying here is that there are 2 instances in which wave diffraction can occur. Instance number 1, when a wave passes through a narrow gap. So when we have incident wavefronts that pass through a narrow gap, we'll have the phenomenon of wave diffraction taking place, whereby the waves would bend. Okay. And we should also put into consideration that we will only have maximum bending of the wave, meaning that we'll have maximum diffraction when the size of this gap is slightly less than the size of the wavelength. That is when we'll have the greatest bending of the wave. Okay, so I said there are 2 instances in which diffraction can occur. So this is just one of the instances. The second instance in which diffraction occurs is when incident wavefronts go around a barrier. So when we have incident wavefronts like this going around this barrier, they would go around this barrier. Okay, so that phenomenon that occurs when incident wavefronts go around an obstacle or a barrier is what we call diffraction. So it is another case in which diffraction can occur. So with this, we have immediately answered the first question. The property that is demonstrated is diffraction, because we have that when incident wavefronts pass through this narrow opening, the waves bend, and that bending is what we call diffraction. Okay, let us get to analyze the second property of waves, which we are calling interference. Interference occurs when 2 waves meet in phase or out of phase. So we're saying that interference would occur when 2 waves either meet in phase or when they meet out of phase. This as well would give rise to 2 types of interference, which we are calling constructive interference and destructive interference. Constructive interference would occur when 2 waves meet in phase. So when 2 waves meet in phase, and as a result, the amplitude of the resultant wave would increase during constructive interference. Then destructive interference would occur when two waves meet out of phase. And as a result, the amplitude, the resultant, the resultant amplitude of the wave would either completely cancel or uh, it would partially decrease. Okay. Then, what is wave reflection? Wave reflection occurs when incident wavefronts of a wave hit hmm, hit an obstacle and they bounce back in the same medium. So what we are saying here is that wave reflection would occur in a situation where we have incident wavefronts that hit, let us call this the barrier, that hits the barrier between two media, and as a result, the wave bounces back in the same medium. So that phenomenon is what we call wave reflection. And lastly, we have wave refraction. Wave refraction is defined as the change in direction and speed of a wave as it enters another medium. Okay, so when a wave enters another medium, okay, let us call this medium air and let us call this medium, let's say, water. When the wave goes from one medium to another and a phenomenon occurs whereby the direction and speed of the wave changes, this is what we call refraction. Okay, so in this case, the best answer was wave diffraction. Then, question 2. A wave whose particles vibrate at right angles to the direction of the wave motion in a medium is described as, remember, we have two types of waves. We have longitudinal waves and we also have transverse waves. In longitudinal waves, the direction of wave travel and the direction of motion of the particles is parallel, meaning that they travel in the same direction. Whereas for a transverse wave, the direction of oscillation of the particles is at right angle to the direction of wave motion. So what the question here is describing is a type of wave which we call a transverse wave. Therefore, here the best answer would be option D. Then question 3. A wave in a ripple tank changes direction as it moves from deep to shallow water. What causes the direction of the wave